Hello everybody. Today I, Vishal V. Bangre, will be explaining you the topic log tables and logarithms. Now, log tables and logarithms are a very important topic in your class 11 and class 12 examinations because in your class 11 and class 12 examinations you won't be provided a calculator, so we must make use of the log tables. Now this is a very simple topic and I'll help you in understanding this topic. So let's get started. Now say I have a number log of x into y to some base a. These x and y are two different numbers and are being multiplied. So log of x into y to base a would give us log of x to base a plus log of y to base a. Now, if we were to take the anti-logarithm on both sides, then it would be anti-log of log x into y to base a, which is equal to anti-log of log x to base a plus log of y to base a. Now what happens is the anti-log and log gets cancelled. So in the end we are left with x into y is equal to anti-log of log x to base a plus log of y to base a. Now say I have a number z is equal to 31.24. Now this number can be divided into two parts. The part before the decimal point and the part after the decimal point. The part before the decimal point is called as the characteristic part. This part is called as the characteristic part, and the part after the decimal point is called as the mantissa part. Now if I were to take log of z to base 10, it should be log of z to base 10, which is equal to log of 31.24 to the base of 10. Now what I can do is I can write log of 31.24 in its scientific form as log of base 10, which is 3.124 into 10 to the power of 1. Now using the concept as I had explained over here, we can write this as log of 3.124 to the base of 10 plus log of 10 to base 10. So now we know that log of 10 to base 10 is 1. So we can write it as 1 plus log of 3.124 to the base of 10. Now this value is what we are going to find out from the log table. This is what we are going to find out from the log table. Now if you don't want to do it this way, I'm sorry, just go back to the slide. Yeah. Now if you don't want to do it in this way by calculating 1 and then calculating this, I have a simple rule which we can use. Now this number which we have is 31.24, right? Now when you have this number 31.24, the number of digits before the decimal point is 2. So you have 2 digits over here. So when you have 2 digits, you can write it as 1 plus log of. Now you shift the decimal point by 1 such that it becomes into its scientific form. So you get log of 3.124. Okay. Now let's just take another example to understand this concept better. Now say I have a number uh, number 281.26. Now, if I were to take the log of this, we can see over here the number before the decimal point has 3 digits. So we can write it as 2 plus log of, what we do is this 281.26 is converted into its scientific form, which is log of 281.26 to the base of 10. Now, I'll be explaining the concept behind how we are doing this. Now, if I had taken a number, say A, and the number had lied between, say, 100 and 10, then this number is a 2-digit number. Now we know that log of 10 to the base of 10 is equal to 1. And we know that log of 100 to the base of 10 is equal to 2. And log of 1000 to the base of 10 is 3, and so on. Now since the number is lying between 100 and 10, so we can say that the log of a to the base 10 lies between 2 and 1. So it is 1 point something. Okay, this is how we find out whether it is 1 or 2. So if you have 4-digit number, it becomes 3 point something. If you have a 5-digit number, you write it as 4 plus that something, which again becomes 4 point something. Now let's take an example to better to understand how to multiply two numbers using a log table. Now say I have these two numbers 35.28 multiplied by 21.62. Now as I told you earlier, this 35.28 has 2 digits before the decimal point, and 21.622 has 2 digits before its decimal point. So we can write it as 1 plus the log of 3.528 to the base of 10, and this we can write it as, since we are multiplying it and we had told the concept that log of xy to the base of a would be log of x to the base of a plus log of y to the base of a. So we're going to take 21.62 and its log is what we're going to add. So since we know it is 21, it has 2 digits, so it will be 1 plus log of 2.162 to the base of 10. Now these two digits, these two numbers, the logs, are what we are going to calculate from the log table. This is what we are going to calculate from the log table. Now I have marked down the points so that it is easier for us to understand. So let me just go to that slide. Yes, over here. So over here, as you can see, over here in the logarithms page, you have the number 35. Actually, let me just use another color. So you have 35 over here. Now the number which we have is log of 3.528, which is log of 3.528 to the base of 10. So 35, and next number is 2. So we go to 2. So we go to 2 over here, which is under the 2 column, and then in the final digit, which is 8, is where add the mean difference. So mean difference over here, 8, as you can see, let me just show it, yeah, 8. So when you come down over here and look for it, it is 10. So the values which are there over here, which is 5465 and 10, is what we're going to add. So what we'll do is we'll add these two numbers. So we take 5465 plus 10, which would give us 574. Yeah, so it will give us 5475. Now since the digit is 3.528, so we're going to put 0.5475, and as we had seen in the previous slide, we add 1 to it, to this log we add 1 to it to get the log of 35.28. So just go here and add 1 to it. So the final value of log 35.28 to the base of 10 is 1.5475. So let's keep this. Now similarly for log of 21, just a second. So 21, since we're taking log of 21.62, here's 21. Similarly, we find out 6, which is 3345 over here, and the second main difference, which is 4. So what we do similarly, which we did in the previous for 35.28, we're gonna do it same way for 21.62. So the first is 3345, and the mean difference is 4, so I'm gonna add 4 to it. You get 9433, so you get 0.3349. Now we are going to add similarly like what we had done in the previous slide, which is here. We add 1 to it to get the log of 21.62. So we go back here and I add 1 to it and I get 1.3349. Now to get the final log of these two numbers, what we do is we add these two numbers. As you can see over here, it's 1 plus log of this, which we have already found out. Then it is 1 plus log of 2.162, which also we have found out. And to finally, as we have done to the base of a, my x into y, log of x into y to the base of a. Similarly, what we're going to do is we're going to add these two numbers. So when we add these two numbers, what we get is 2.8824. Now we take the anti-log as I'd shown you over here. You can see, let me just go yeah. As you can see here, we take the anti-log of x to base a and y to base b. Anti-log. Now this is a simple trick which we can do. What we're gonna do is, this 2 is there, right? We're gonna take 10 and the power of 10 we take it as 2. Now similarly, if you would have had 3, you would have taken it as 10 to the power of 3. And then which is left out, which is 0.8824, this we take the anti-log of this part. So to make you understand clearly, I've already marked down the points. So the anti-log of 0.8824 is same again. You find out 0.88, which is over here. Then you take 2, which is 7621. So I write down the point 7621. Then you go to the mean difference of 4. So it is 7. And you add it to this. You get 8267. So you get 7628. So what we're going to do is we are going to convert it again into a scientific form, and we're going to put a point over here. So we're going to put a point over here. So it becomes 7.628. Now I told you that we're going to remove 10 to the power of 2 over here. So what we're going to do is we're going to multiply it with 10 to the power of 2. And we finally get the answer as 762.8. This is what the answer we are getting. Now I've divided this video into different parts. In the next part, I'll be explaining you division and different operations as well. So the answer over here is 762.8. If you use a calculator and do it, you get it as 762.75 and some other digits as well. So you don't have to worry too much about the answer, because the log tables are accurate to only some digits, which is like almost like 4 digits. There's some uncertainty in the final digits because it is having only till the 4 digits, and that is more than enough. So what we are going to do is in the next videos I'll be explaining you how to do division. So please like, share and subscribe, guys. Thank you very much for watching this video.